All right, today we are going to move on to what's called graphing systems of linear inequalities. And so if you recall from earlier in the unit, we solved a system of equations by the graphing method or substitution or elimination. So what that means is this time we are going to be solving linear inequalities in a system, which means more than one inequality. So it's kind of hard to tell up here, but let's do a definition here of system of inequalities. So will you add that it is two or more inequalities, relating the same variables, meaning they have both x and y. Relating the same variables. So for algebra 1, we will just have two equations. They both have x and y. So this right here is a system of linear inequalities. And so when we solve these, we are always going to graph them. So we are going to do what we did yesterday with graphing and shading, but we're going to have two lines or dashed lines on one graph, and then we're going to have double shading. Okay, so let's go on. I want to define what does it mean to be a solution of a system of inequalities. So a solution would be all ordered pairs. All ordered pairs. All ordered pairs of numbers that satisfy each inequality. All ordered pairs of numbers that satisfy each inequality. So the purpose of our shading is we are basically coloring in all the answers. So whatever we're shading is going to represent all of the ordered pairs that are solutions. So our plan here is to just separately graph the inequalities, and then we're looking for that double shaded area. Okay, so I'm going to do a couple colors here. I'm going to work with the first inequality in blue. And so when I look at this, I say to myself, this is slope-intercept form. So my m is 2, my slope is 2, my y-intercept is 3. And before I go any further, make a decision, is it solid or dashed? So this is just greater than, so this is dashed. Okay, let's put that on the graph. So my y-intercept is 3. And so my slope is 2. So that's going to go up 2 to the right 1, up 2 to the right 1. And I'm just going to fill my whole graph up in both directions. Down 2 over 1, down 2 over 1, and just keep going until I run out of room. Okay, it's dashed. So I'm going to do my best here to make a dashed line through here. So I'll just put little dashes along the way. Okay. Now let's figure out where to shade. So let's plug in that 0, 0 test point. So I'm going to compare. Is y greater than 2 times 0 plus 3? So is 0... I think I said y. Is 0 greater than 3? No, that is not a true statement. So that means since 0, 0 is right here, I don't color that in. I jump to the other side of the line. Okay. So all of this is colored in. Okay, I'm going to switch colors here because I have a second line. Now, if you want to calculate the x and y intercepts, go ahead. I'm going to go ahead and rewrite this in slope-intercept form. So I'm going to move over the 3x. So that gives me 4y is less than negative 3x plus 12. Divide by 4, divide by 4, divide by 4. So y is less than. So that just stays negative 3/4 x. 12 divided by 4 is 3. Okay, so there's your m, there's your b, And let's put it on the graph. So 1, 2, 3, okay, same spot, which is fine. So down 3 to the right 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then I'll go backwards. Up 3, 1, 2, 3, 4. Up 3, 1, 2, 3, 4. Okay, less than another dashed line. Okay, so I'm going to come through here and go dashed, 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 dashed. Okay, now I need to shade. So plug in your test point. Now I'm going to go back to the original inequality. So basically I'm plugging in a 0 for x and a 0 for y, and you end up with 0 all on the left compared to 12. So 0 less than 12, yeah, 0 is smaller than 12. So that means I'm shading, here's 0, 0. I'm going to shade that ordered pair, which falls under my line. So I want to color in wherever under is. And so here's what I want you to see. Look at the double shaded area. I'm going to make it a little darker. So I'm going to highlight by making it a little bit more shaded in. This area right here that is now green, that's the answer to this problem, the double shaded area. So what that means is any ordered pair in that double shaded area is a solution. If it's not in that double shaded area, it's not considered a solution. Okay, so we're looking for basically a double shaded area. All right. Well, I want you to try the next one. So please stop the video, go through that entire process. And if you want to go on to 2 and 3, go right ahead. And then when you come back, I will walk through the solution. Okay, I'm just working through the first one because it is in slope-intercept form. Now sometimes when I have a slope of 1, I skip some points. So I go like this. Instead of going down 1 to the right 1, I'll go down 1 over, down 1 over. So I have a little bit of space. Now, I usually do this if I have a dashed line because it's going to be hard for me to show it's dashed. With this one being solid, I didn't necessarily have to do that. Let me make a better line here. All right, it's a solid line. I thought about that at the beginning. So if I'm going to plug in 0, 0, it's going to say 0 is greater than negative 0 plus 2. Well, that just says 0. Is 0 greater than or equal to 2? No. So that means I don't color in where 0, 0 is located. I color in on this side. Okay, if you did x and y intercepts, that's fine. I'm going to go ahead and do slope-intercept form. We should get the same line. So I'm going to take away 2x. And I'm going to divide off 4. So y is less than. So negative 2/4, I'm going to reduce down. I always reduce my slope down to negative 1/2. 4 divided by 4 is 1. So 1 is right there. I'm going to go down 1 over 2, down 1 over 2. Just keep doing that. Up 1 to the left, 2. Okay, now my lines are starting to separate a little bit. They were pretty close there earlier. Okay, back to the top. That is dashed. Okay, so I guess I'm just going to make really tiny, maybe I'll just make dots in between them. That way it looks dashed because those are pretty close together. Okay, 0, 0. And go back to the original equation. So 2 times 0 plus 4 times 0 is less than 4. But the quicker way is just to recognize 0 plus 0 is just going to be 0 on the left. Is 0 less than 4? Yeah, that's true. So 0, 0 is slightly below the line. So here's my shading. Now, I'm looking for the double shaded area. So this one's kind of tricky. It's a really, really tiny area here. Let me change my color. And it's right here. It's where these two overlap right here. So when you're graphing, as you're adding your second shading, look for the double area. Okay, and so as you're looking for the double area, as you see you're drawing over it, it'll help you identify your solution as you're going. All right, pause the video again, and if you haven't done 3, please do number 3 next, and then come back. Okay, these are in slope-intercept form. M is 1, B is -2. -2, up 1 over 1. So let me see what I'm doing, dashed or solid next. Okay, this is dashed. So here's what I sometimes like to do. I like to skip some. So instead of just going up 1 over 1 and putting my dot, I'm going to go up 1 over 1, up 1 over 1, and then put my dot. Up, over, just to spread it out a little. I'm still doing a slope of 1. I'm just not showing every dot, because I need to put a dashed line in between it, and it's going to be really hard otherwise. Okay, so I'm going to come through here, and now I can just do these dashes in between it. And I'm not even going to do it in between those because they're too close together. Okay, 0, 0. Actually, I want to show you something else. Here's what I want to show you, another method. If I'm in slope, no, I'm not even going to do that. Let's just stick with 0, 0. I don't want to throw anything new at you. So if I have this, I have 0, is 0 greater than 0 minus 2? 0 is greater than -2, true or false? 0 greater than -2, yes. All right, 0, 0 is kind of above the line, so I'm going to shade all over here. All right, let's do the second line. I've got my M and B. So 1, 2, 3, and it's a slope of -1/3. Down 1 over 3. Down 1, 1, 2, 3. So I'm going to go up 1, 2, 3. Up 1, 2, 3. Okay. Come back. This is solid. So just make a regular line. And then test point. 0 greater than or equal to -1/3 times 0 plus 3. Okay, that's just 0. So is 0 greater than or equal to 3? No, it's not. It's smaller. So 0, 0 is right here. Don't color that in. Go to the other side. Now I'm looking for my double shaded. So it looks like I'm double shading right here, not double shading here. But I'm going to come back and reinforce. So my double shading is all right along this area right here. Okay. So the reason I count my slope across the whole coordinate plane is if I make a line that's curved, I'm not going to identify all of my solutions accurately because I'm looking for that double area. Okay. Look how pretty that is. Isn't that fun? All right, go to this back page here, and I'm not sure that your paper is going to show this as well as the video. Show the intersection clearly, then let's write a system of inequalities. Okay, here is the intersection, and when it says intersection, we're looking for the double shaded. Okay, let's do the first one that is in blue on my screen. It is horizontal. So it's in the form of y equals a number. So I'm going to leave a space here. It's going through 2 on the y-axis. So it's going to be some kind of inequality compared to 2. All right, dashed. So it's just greater than or just less than. Now look for the pink shading. Not the pink, look for the blue shading. Okay, so see how the blue shading is under the line? So all of the y's that were less than 2 were shaded. Okay, so y is less than 2 is the blue line. I'm going to switch to pink. Okay, let's do y equals mx plus b. So this might be a little bit hard to see. There's -1, there's -2, there's -3. So the y-intercept is -1. And then let's do our slope. It looks like it's going up 1 over 2, up 1 over 2, up 1 over 2. So the m is 1/2. Okay, so it's going to be y. Let's come back to the inequality. 1/2 x minus 1. Okay, it's solid, so it's going to be greater than or equal or less than or equal. So here's another thing to kind of do the opposite of figuring out what the symbol is. Do you see how, look at just your y-axis. Do you see how everything shaded is above the line? So think of it as all your y's are greater than your line. So this is going to be a greater than or equal symbol for our system. Okay, so that is your system. So I want you to pause it and try the last one here. Try to come up with your system of inequalities. Okay, this is really hard. I need to fix my example here. Okay. The first line is x, because it's vertical. It's a dashed line, and it's going through -3 on the x-axis. So all of the x's that are bigger than -3 are being shaded, so that's why I did a greater than sign. Now, the second one is hard to see. So your slope here is -2/3. My graph has not worked well over the years. The y-intercept is 0. Okay, so it's going to be y something in a minute, -2/3 x. You can write +0, but normally we wouldn't see that, so I'm going to take that out. Okay, it's solid, and look at your blue. It is shaded under the line, because here are my y's I'm looking at. So it's going to be a less than or equal as our inequality. Okay, so you kind of have to go backwards with your logic when you're trying to write these systems. Okay, if you have questions,